Hey guys, I'm in my kitchen making these videos, and I wanted to start off by saying thank you for reading. That'll help you understand what we're going to talk about. I just wanted to cover a few of the main topics in this section. So, if you haven't read it, please go back and do so. But we are talking about studying populations, and next to me over here is my book. So if I'm looking that way, that's what I'm looking at. Um, please feel free to email me if you have any questions. If you're not understanding how Office 365 works, please do that. But here we go, we're going to get started. So when we're talking about populations and how we count different populations throughout the world, the easiest thing to do would be direct observation. That is when you can physically count every single member of a population. So it makes me think of if you were all sitting in the classroom with me, I would count a population of 18 of you, and I know that's 100% correct, assuming you were all here that day. So that's the easiest way to do it. Then the next kind is the indirect observation. That would be kind of looking for homes of an animal, maybe. So the book gives the example of looking for mud nests for the cliff swallows, which is a type of bird. And so if you know that each entrance has only one hole, you might assume that there are 4 swallows living in each nest. And if you counted 20 20 holes, you would say, okay, there's 20 holes times 4 swallows, which would be about 80 swallows. Again, it's not completely accurate, but it's a way of indirectly observing how many there might be in a population. Now, I would say maybe you walk down your street and count the number of houses, and you can assume that maybe 2 to 4 people live there, so you could then multiply to figure out how many people might live on your street. Another way is called sampling, and it has to do with estimating. It says sometimes that most times, there's not a way to physically count each member of a population. So we do something that's called sampling. And it's basically an estimation. And one way to do it is to get a small area. So say you were out in your yard and there were a bunch of dandelions. They're coming, they're not here yet. But maybe you mapped off 1 meter by 1 meter square, and you counted how many dandelions were in that square. So maybe there were 10 per square, and then what you did is you were able to measure your whole yard. So maybe your whole yard consisted of 100 squares. Okay, so you would do 100 times 10 because you found 10 dandelions, and you would figure out how many dandelions might be in your yard. Are you going to be completely accurate? No, but it's a good way to give an estimate, right? An educated guess. So they might do that with trees in a forest. They might take an area probably bigger than a meter by a meter, but they would do that and say, okay, there are this many trees in this small space, and we know the forest is this big, so we can multiply to figure out how many trees there might be in the forest. And then the last one is the mark and recapture. This one's pretty cool. So you may have seen this on during Shark Week, where they want to go and put a tag on a shark, and they want to be able to follow it around, see where it goes. Well, it's kind of along the same lines. So they can do this with many animals, and the book talks about doing it with turtles. So they're in an area and they see a bunch of turtles, and what they do is they can put a little mark on them, whether it's just a little spray paint on their shell or something that's not going to harm them. And so say they do that on a Monday. They mark 15 turtles, and then they go away, the people do, and then they come back the next Monday and they see as many turtles as they can, and they count those that have already been marked, because hopefully some of them will be, but then they're most likely going to see new turtles that haven't been marked yet. So they will mark those ones and then count how many they've had, and then they'll go away, they'll come back the next Monday and see how many they can do, how many they can find. Now, they might do this for a month at a time, they could do it for a whole year to project how many turtles are in the area. Alright, so I'm going to turn the page. I'm on page 16 now. Changes in population size. Okay, our population as humans is changing all the time. It's going up, it's going down, and animals are the same way. Now, the two easiest ways for population size to change is with birth rate and death rate. Okay, when a new animal is born, the population size goes up. When an animal dies, the population size goes down. So that's a really easy way to figure out what the population size is, or adding or taking away from a population. Now, there's two other ways that happen as well. Immigration, which means when a new animal moves into the population. Okay, some of you may have moved to a new city in your lifetime. That means you immigrated to a new city with your family, and now you are part of a new population. What it starts with, but the other word is emigration, and it's very similar, but it is different. It starts with an E. That means that you moved out of the population. So if they were going to count the population again and you moved away, you would not be included in that population. So if an animal moves out of its habitat for whatever reason, we would say it emigrated out. And this one's easy to remember because it starts with an E, which means exit. You exit the population means you emigrated the population. And I like page 17. It's showing a change in the rabbit population. There's a nice graph there, and it gives a reason why. If the rabbit encounters a fox, it may be part of the death rate. All right, I'm going to turn to page 18. And there's a formula that you can figure out to understand what the population density is. You can look at that. We're not going to spend a lot of time on that. And then let's move on to limiting factors. These are what prevents a population from growing, and that's usually the goal in most cases. Now, there are some species that we don't want their population to grow, but that's okay. So a limiting factor would be food, water, space, and weather conditions. Okay, if a population of animals does not have food or water or enough of them, then the death rate will go up. That means, and the population will go down. Okay, if not everybody can get fed and not everybody can have enough water, you will start seeing animals die. Another thing that can limit them in their increase in population is the space. We all need our own space to live, and so do animals and plants. If there's not enough space in the forest for another tree to grow, well, that tree's not going to grow. If there's not enough space in a nest for a certain amount of birds, then they may kick one out. Okay, so if you don't have enough space as an animal, that could be something that prevents your population from growing. And then the last thing is weather. We're kind of going through the transition from winter to spring, and weather conditions such as temperature and the amount of rainfall can limit population growth. Also, like a natural disaster such as a hurricane or a flood or a volcano, something that is out of their control, those animals, due to that weather or that natural disaster, that can cause their population to go down. Okay, so that's about it for that section. You're going to be doing a few more worksheets and some activities on this part of the section. And I'm going to be looking for maybe some virtual labs. There were some really cool labs that we could have done in the classroom, but I'm not sure if everybody would have the materials, so I will be working on that to be able to do that. So keep an eye out. Hopefully that you can get your homework done through Friday, and then on Monday we'll start something new, but it still may deal with section 2 as well. Again, I hope this is not overwhelming for you. We will get through this together. You guys are doing an awesome job, and just let me know if you need anything. All right, I'll see you guys later. Bye.